Hello, I'm Shiva. I'm going to develop the project, which is the part of the RAID. I'm going to present that one. And the project is about the fuel choice analysis for the T-side transport sector. So in this, I'm going to present and the team we have a good team of both from Teesside University and the Durham University academics and as well as the research fellows and some other teams. So first I go through the what is the background and importance of this project, why we are doing the fuel choice, and what type of the project we are going to, and why we are selected will be TVCA or the Teesside Valley. Then I will go through the aim and objective of this project, and later on we have discussed about the current scenario of the transport in Teesside Valley, and then we will discuss the what will be the optimized solution in future we can do, and later on we will discuss the what will be the future plan of this project. T-side will combine 30 with the TVCA because this is not another like Brock Council or something like that. They and TVCA combined 30 was created, which is a part of the six like Darlington, Middlesbrough, Stockton type thinking. The population is around 700,000 around, and their area is about 360 kilometers square, and total GDP is 79 billion pound. And the most good thing is that this area, the T-side, is 90% population is the urban area. It means that the urban area, the people are using, they are the mixed mode of the transportation of high quality transportation like cars, public transportation is also required. So that is another part. And purpose of this T-side Valley driving the economic growth and job creation in this area. And secondly, focus area transportation, infrastructure, how the transporter, how the infrastructure can be skills people could be produced, and the most importantly, that they are working to be continuously decrease the CO2 emission. So we can see this is a good news for the Teesside Valley. With the passage of the time, the CO2 emission in this area is going to be decreased. So TVCA also have the net zero commitment. The Net Zero Innovation Center is a part of that commitment, and that area is assigned to be to net zero example for the government. So they have also some objective, and they have some also commitment. Number one, UK's first decarbonization heavy industrial cluster by 2050, because Teesside Valley is one of the most industrial cluster of the UK that can be case. So that will be selected to be the most decarbonization sector by 2050. They have the goal. 4 gigawatt for hydrogen production at the part of that commitment, and thus then develop a national hydrogen transport hub. That is a part of their commitment, and they want to be a quantified exemplary system that can be replicated into the national level if there's someone going to be the international at the part of that. They have also the environment commitment, the planning green spaces and at homes, their good efficient home, as well as the support the 1,000 small businesses, which can be the net zero based businesses, and that can accelerate our effort to decrease the CO2 emission and with the economics. That is the most important part. And definitely training and green employability. So we can see that CO2 emission in Teesside Valley, the major come is from the industry is 62%, because definitely the industry is we have the industrial hub, and the second one is coming from the transport, which about the 17%. That area should also be taken if we are going to be net zero goals. So in this sector, Teesside TVCA and the government of UK government also have the plan. Teesside International Airport should be decarbonized or should be in 2030, and first net zero airport about the 2035. And they are also trying to increase the 200% EV public e-vehicle charging station, that the people who are going to be use electric or the hybrid electric vehicle, that can be facilitated with the part of their facilitation. And of course, there we have aim, the TVCA aim, we are the part of Teesside Valley, fully decarbonize local transport sector by 2030. So there is a basic economic statistic. Northeast GDP growth is higher than UK, about 3%, which shows the potential of that one. But the another not bad, the below is the UK average. The GDP per capita is below than the UK average, and definitely not have the below UK per capita income as compared to the South. So that will be, but this shows also the potential for economic and the financial growth can be happen in this area. And this project is about the transports. So there is a constant increase. The northeast road transport, it continuously increase up to the COVID. Definite COVID, the movement have restricted. So it will be, we can see the
sharp decrease. But still, after the COVID restriction was lifted, and then again increase is start into the utilization of the vehicle and the movement of the people for their work, for their homes, for their anything. So what is the hydrogen? Because we are the part of the RHEAP, and RHEAP is mostly focused on the hydrogen. Hydrogen is taken as one of the major or key component of the decarbonization effort towards the net zero goal of commitment. Hydrogen can be produced by different sources. The source of the hydrogen produced that can be categorized by their parts of the blue hydrogen, green hydrogen, clean hydrogen, low carbon hydrogen. This is the first part. The second part, how the hydrogen can be transported and how the hydrogen can be stored to the use of applications. So that is the one of the most important key. Until unless, for example, we produce the hydrogen, but we need the transport of hydrogen, and we need the like pump to pump the hydrogen in any case. So the transportation, production, transportation up to the use of applications, that is one of the most important, and that is the one of the most important challenges in hydrogen infrastructure. That's oil, because oil is already the established infrastructure source, established infrastructure of movement. Like we have the diesel pump, petrol pump, like vehicles, train, everything, and LNG vessels, everything. So this supply chain is very important. That could be taken off in this scenario. So now I will shortly go to the aim and objective of these projects. We have to, first of all, our aim, analyze the current and future fuel demand of the transport in this CV-wide area, which kind of the treatment in BN, and for the each subsector, road transport, air transport, rail transport, and of course the marine transport. Then we have to map out the future potential. If we have what type of the current fuel we are using, so in future what type of the fuel we can be used in order to reduce the greenhouse gas emission, and how it will affect the cost of the people who are users. So that is the one of the most important aspect. And the third, we will, for this one, we conduct the technical, economic, and environment analysis to identify all these current scenario and what will be the future scenario in case of the greenhouse gas emission, and the cost paid by the consumer. Our focus is cost paid by the consumer. Just like I have a car, so how much the petrol I am taking from the fuel station. So what will be the effect? And of course, the fourth one, if we are going to be a transition, and what will be the new future. So we need a prospectus of the general audience, the general people who are going to be used, as well as the industry related people, how they think either it is possible, either this technology is mature, and what the people think about that. So that is based on the workshop and the survey analysis progressive. So methodology. The first scenario is based on the what is the current situation, that based on the conventional fuel we are using. The second scenario, we have given the midterm plan. We can't go to the any hydrogen to the blink of the eye. So there is a smooth transition should be happen which involve the technological development, as well as the investment, and the most important thing, the people motivation to use that fuel. So that is the midterm scenario. And the third scenario is about the future plan of how the hydrogen can be used. And we are going to be realistic. We are planning, we are studying about the either in 2000 we can go 100% hydrogen, maybe not. So we are thinking maybe 25%, 50%, 75%, and we are trying to be simulate and to be predict this all scenario based on that. For this purpose, very simple methodology and work plan we have been charted out. First of data collection about the transport, what type of the transport, how many vehicles and they are moving, how many the CO2 emission they are doing, and what will be the emission factors if they are using any fuel like diesel. If the diesel is combust in a one car, so how much the CO2 emission per liter or the per kilometer, what is the petrol, and how the CO2 emission related to the when it used in the bus. So similar, all type of the information will be collected, and that can be collected with the environmental database, which is called the DEFRA. And then we have the fuel cost. We are taking the fuel cost that available on the pump. So the person, like I am taking the 1.31 pound per liter. So in my car, so we are taking that cost because this project is related to the people analysis. Then we have developed a model development. how much the CO2 emission using the value, how much the cost people bear, and definitely the third one will be the distance traveled. And after that scenario, we have with you an analysis the what will be the future plan. Review and analysis will be defined 2030 scenario 2 and scenario 5, and we will after that the most important target, we will be develop a report and with some recommendation how the hydrogen roadmap can be obtained in this scenario. So this is the current scenario as we have done this, the latest the work we have done. So in this scenario, this I'll just clarify, this is only about the Teesside Valley. So we are taking the Teesside Valley. So in Teesside Valley, we can see that the CO2 emission is mostly done by the road transport. The road transport have done the most CO2 emission because in UK we are the mostly private vehicle driven nation. We are mostly using that one, and similarly the rail transport 12% and 10.5%. But and if their CO2 emission, we can see that the cost also be higher in the road land transport. The reason is that mostly people use the cars, mostly people use the passenger vehicle they are using, and it can be evidence the main due to the about the distance traveled. So distance traveled by the road transport is also high. In case of the plane, they maybe have the short flight, but they can get the high distance travels. They can be also be consumed, but their CO2 emission is about the 10 to 12% air transport and the train transport. So share of the CO2, we can see that as we have seen 97% of emissions is coming from the road transport. That because most of the people are using, if a train carry maybe 200 passenger in a one go, but a car can carry sometime one person, sometime two, maximum 4 or 5, or maybe any 7-seater, they are one. And the rail and air transport have the less emission as compared to that one. And right now we have working on the maritime data, because maritime data is not available yet, as will be available. So we make that part in our study. So we also we assumption our study, we have also calculate this study with the, we compare with the TVCA have some, they have done some studies, so we can find we have the less point in 20%, but there are the some assumption maybe we can't reach that level. One is that we have not take the goods transport by rail, that data is not available. Exclusion of maritime data which we are not have. And secondly, we have the data about the how many craft move from the Teesside airport, but for the passenger craft, we have now the data commercial flights from that craft move from Teesside to where. But for the military aircraft movement, other craft movement, we don't have information, so we have excluded from our study. So road transport, I have just explained in the last slide about the methodology, how we can we calculate. We have collected the transport emission data from the road transport from UK road traffic statistics, and then we have the calculate CO2 emission by using the CO2 emission factor. The good thing is that we consider how much the distance traveled by the cars, how much the distance traveled by the buses, how much the distance traveled by the logger vehicle, how much the distance traveled by the buses, and all of that, and how much the CO2 emissions they emitted by the E type of the transport. We can see that one. The limitation is that TVCA is a different authority, so the data for that is not available. So we can take the data of the UK national data and the Northeast data, and then we will calculate. So we can see that but same car and taxi have the major share. The second part is come the buses, and then again high goods vehicle and light good vehicles. They can also come. And similarly, in the second graph, we can see that how much the distance miles traveled in 2023 by these vehicles, and if the miles traveled, if the person how much the cost spending their fuel, the people have taken the fuel, how much the cost is spending. So we can see the car and taxis, private owned vehicles, still have the major part. Same in the rail air transport. So this is the rail. We have the map from the TV Valley. So we have considered the rail pass through this within this area So we have considered that one, how much the miles the rail have traveled. So we have considered the passenger trails by using network rail data, because network rail and the national, they have published their timetables. So we have calculated that timetables which the train is going in this area. That was a little difficult part for us. The reason is that the trains are coming not available, even from train station not available. So we can find requested that from network rail, they're given the some publications. So we have calculated from if a car if a train enter into the Whitby and then leave from this area, so how much the travel, then we have their like lines calculation, and then we make that one. And similarly, in case of the air transport, we have taken how many commercial flights move from Teesside Airport and how many commercial flights will be landing in Teesside Airport. The training flights, the data is not available how much they fly, how much the distance they fly. Similarly, the military aircraft movement, which were not also available. So these two factors we have excluded from our study because the data not available. And the third one, in rail transport, did not consider the goods rail, because in all the timetable the goods transport is not available, how much time this enter and this other, and it was not available in the network way. We still in coordination that if they can provide that data, and we are considering if the goods transport, how much the goods train will be passed through this area, and either the goods is be landed here or either be take off or load off or not. So we can see that same is that in air transport have the higher 154 as compared to rail transport, but their emission is almost similar. So still we have identified we have to more work in the road and land transport. That is the more main contributor in this area, and definitely we can't ignore the rail transport. And we have the very good fact that in our area the train bus, the most of the trains are the diesel, still is not electrified. So that another transition, if we go for the electrified diesel, that could be far in 2050. Definitely the hydrogen is a far dream. So definitely the men see the dreams, and sometime it will be happen, and of course in future it going to be happen. So we also see that some study, as we are seeing that we can't go from hydrogen to the blink of the eye. So we can go for this some transition. So we just make a study only for the bus segment. If we have bus going to be see, so we can see from 2022 we make study, most of the bus is a diesel. With the passage of the time, the diesel bus are going to be replaced with the hybrid electric vehicle and some part of the electric vehicle. So in 2031, the last diesel bus can be maybe over in our study, and of that. And after that, the major contribution will be the hybrid electric vehicle in 2040, and it would be great if the electric buses compared to hybrid electric vehicle will be the more take up part. So this study shows that the annual emission can be reduced, and similarly the cost of the fuel be increased. And we are going to be same study for the only this is the bus we are going to do for the cars. We are going to be the high goods vehicle and the light goods vehicle, same as goes to the in case of the train. The train we have the two option, either we are going to current diesel and electrified, and in future the technology available what will be the hydrogen map here. In case of the air transport, that is the most important, and I hopefully that will be more happen, because the TGC had more commitment in 2030 and 35 that going to be the net zero airport. So that could be like a synthetic fuel from the renewable sources could be replaced that one. So similar study we are going to be doing. So what will be the midterm scenario and what will be the future scenario? So future plan, we have 10 plan. Definitely users and the industrial partner and the industrial technology is important. So in our perspectives, we are going to midterm plan. Why we are midterm plan? The reason is only we are not going to be do the hydrogen in blink of the eye. So either the electric vehicle is available. So what is the alternative for blue, which is technically mature? So in future, what will be the hydrogen value? So we going to be make a survey that could be part of the general audience, as well as we are collecting from data, not only the reported literature, because as well as we are also consulting and we are also conducting a workshop and the survey based with the industry. So what do you think? Either this technology is available at that moment or not? So all the studies based on the at that technology is more available or not. For example, we have planned maybe 2050 the hydrogen will take part of all the transportation, but the industry or the some protection can be tell either at what level of technology now and what will be the projection. So in 2050, we can reach this technology like hydro production, and especially in case of the car, like the last project they and done. So either we have the hydrogen fuel pump in this road, maybe in Cleveland Road we have the hydrogen fuel pump in 2050 or not. So these kind of the questions we are going to be asked the industry as well as the general public. Either they are willing to be part of that field, because transition is always be very difficult and people are reluctant to change. Similarly, for example, I give just one example: electric vehicle, and I have the like petrol car, and someone has the electric vehicles. People are thinking, okay, I can be stopped anywhere when my battery is finished. So for the petrol car, I can take the fuel. So such kind of the reluctance, such kind of the resistance, some kind of the adaptation intensity, the people also very important. They are going to be used. So in this way we can create the co-creation and the transition here, and we are the part of the transition in next 20 or 30 we are that going to be again. And why we are going to be the transition? Because the situation can be changed from the last 1 year 2 or 3 months. The oil is going to be another main factor due to the politicals and many things. So maybe the this transition slow or not, maybe slow, but I hope it will not be slow. So I will be thank to the REHE project, which is funded by the UKRI and Prof. Nashwant Dawar and Nashwant Daud about the PI of this project, and the Tony Risky, and also the project manager Mr. Simon Barsha, which is coordinating all of the project. So these are the sources like the governmented sources, and we have collected the data and built our model. Thank you very much. If you have any question, please.